Hi, hello and everyone, and in this video we will be discussing some questions on quantum mechanics. So this is some basic questions which is related to your atomic physics also, because quantum mechanics starts with Bohr atom model, because after the discovery of Planck's constant, the development of quantum mechanics took a correct phase. Then there are a lot of development took place in history in quantum mechanics. Okay, so here I'll be discussing some questions, particularly in this part. I'll be discussing about 40 questions for your SET, and TRB related questions. For SET and TRB, it's a objective question. Hopefully, that will be helpful for your direct examination. For net, it will be helpful to revise your concepts. Okay, so I will come up with some derivation based problems in next session. Okay, so in this session I will be discussing some basic questions, objective questions. So these are very easy questions once you gone through your atomic physics and basics of quantum mechanics, right? So let's move on to our session first. Okay, so right, so as you know, the first question, the Bohr postulated in his model the quantization of angular momentum. So one of the postulate of Bohr atom model, the first potential energy, excitation potential of an atom is 10.2 volt. Its ionization potential must be is about 10.2 volt. Okay. So the angular momentum of an electron in an hydrogen atom can possibly be, so once it is quantized, it is L into H cross. So you will be having H cross is nothing but H by 2 pi. So option B is correct. Okay. So no two electrons will have all the four quantum numbers same. So this is nothing but the Pauli's exclusion principle, that is it is known to everyone. Once you do physics, obviously you can't escape from Pauli's exclusion principle, right? Right. Next question. The Bohr atom, according to Bohr's principle, the relation between the main quantum number, that is the principal quantum number n, and radius of the orbit is given by r is proportional to n square, because Rn is equal to n square h cross square by me square. So we can write Rn is proportional to n square. So option C is correct. Option C is the correct answer, right? So we move into next question, question number 6. The hydrogen atom in a D state. For this stage, the values of Mr, this is actually, it should be written as Ml, it's a magnetic orbital quantum number, right? So for S, we have a orbital quantum number or azimuthal quantum number as S is equal to 0. For L, we will be having 1. For P, we will be having L equal to 1, and for D, we will be having L equal to 2. From vector atom model, we can write 2L plus 1 values. For D, we will be having L equal to 2. So we are able to write 5 values. So that is minus 2, minus 1, 0, plus 1 and plus 2. Right. So, and next question 7. If element with the principal quantum number n greater than 4 were not allowed in nature, the number of possible elements would be. So please try to solve this and comment the answer in the comment box. Okay, for this question only. I will give the answer in next session. The ionization potential of an hydrogen atom is 13.6 volt. The energy required to remove an electron in the second orbit of an hydrogen atom is about 13.6 volt. So if you have any clarification with this question, or if you know the answer properly, you just give a derivation and for this question. So which of the following is the correct statement? So according to these statements, any particle in motion, whether charged or uncharged, is accompanied by matter waves. Okay, this is known to everyone. Okay, according to de Broglie hypothesis, lambda equal to h by p, that will obey for all the particles. Even macroscopic object also, it has matter waves. Okay, but it's not realizable as the matter waves of electron or charged particles or microscopic particles. So all the matter in the universe can can be expressed in terms of a matter waves with the help of lambda equal to h by p. Right? So we move into question number 10. Question number 10. So Davis and German experiment relates to electron refraction. So Davis and German experiment, as you know very well, it's the experiment which helped to prove your our de Broglie hypothesis experimentally. So that's what the Davis and German experiment is important. This experiment is based on electron refraction. Okay, so once we have electron refraction, then only we are able to get the pattern. Okay, it's a diffraction is the wave nature of our light, right, or particles. Okay, so which of the following statement about the energy in a quantum is true? So energy in a quantum, which is E equal to h mu, is a relation where energy can be expressed in terms of quanta, right? So E is equal to h mu. The frequency varies directly with, sorry, energy varies directly with frequency, right? So option A is correct for question number 11. A is correct for question number 11. For 10 it is C. And question number 12, the wavelength lambda associated with a particle of mass m moving with the velocity v is given by lambda equal to h by p. This is nothing but de Broglie relation, lambda equal to h by p. Okay, so de Broglie's hypothesis is associated with the wave nature of all particles. Okay, so neglecting the variation of mass with velocity, the wavelength associated with the electron having a kinetic energy E is equal to, so we can write E is equal to half mv square. Since we have a kinetic energy E equal to half mv square, so m is neglecting the variation of m, we can write v square is equal to E, and we write E is equal to square root of E. So option A is correct. So if you have any clarification, just comment it down into my comment box. I will try to explain that. Okay, so and question number 15, matter waves show diffraction. Okay, so it's a wave nature. The wave nature of the particle will show diffraction. If a charged particle of mass m is accelerated through a potential of v volts, the de Broglie wavelength is proportional to. So we can write lambda equal to h by square root of square root of 2m EV, 2m EV. So square root is inside. Okay, so h by square root of 2m EV, right? So we can write lambda is inversely proportional to square root of v. So we can write lambda is proportional to v power minus 1 by 2. So option B is correct. Okay, so according to Schrodinger, particle is equivalent to a wave packet. Okay, particle is equivalent to a wave packet. Okay, so then 18 of the following moving with the same velocity, the one which has the largest wavelength is an electron. For 18 and 19, answers an electron. So try to comment the answer why it is an electron. What fixes, whether it's a mass or a velocity, which help us to fix the longest wavelength. Okay, please try to comment the answer on the comment box. Okay, the expression psi r comma t mod square stands for the position probability density. Position probability density. Right, psi square is nothing but it's a probability density. Okay, it's a position r comma t is there, so it's a position probability density. The expectation value of a momentum p is, we can write, in general we can write integration of psi star a psi d tau is tau, because a is an operator. So here we have, instead of a operator we will be having a corresponding momentum operator here. So integration of psi star h cross by I del into psi d tau. Okay, so which is nothing but psi star h by I del psi del d tau. So option C is the correct answer. Option C is the correct answer. Okay, right. Then we will be having next question. Okay, the traveling harmonic waves have a constant magnitude at greater distance and for which the normalization integral diverges represent a free particle. Diverges represents a free particle. It's a diverging particle. Okay, the phase velocity and group velocity of a de Broglie waves in free space are related by Vp into Vg equal to c square. C is nothing but velocity of light. And question number 24. The de Broglie wavelength of a material particle which are in thermal equilibrium at the temperature T is given by lambda is equal to h cross square, sorry, h by 2 pi. Option A is correct. 2m kbt. 2m kbt. Okay, k is the Boltzmann constant. Okay, k is the Boltzmann constant. We can move on to next question. Question number 25. Question number 25 we have. Okay, just a minute. Just a minute, for a couple of minutes. Please wait. Yeah, here we have 25th question. Which one of the following pairs of a phenomena illustrates the particle aspect of wave particle duality? Photoelectric effect and Compton effect will signify the will give the particle nature. Compton effect, Bragg's law is based on your wave nature, and Pauli's principle, it's vector atom model, and again Bragg's law is the wave nature of light. So obviously option C is correct. Option B is correct for question number 25. And 26 I will discuss in next class. It contains some derivation part. Okay, I will discuss this in next class. Okay. The uncertainty principle holds for microscopic particles only. Okay, so obviously all the materials are made up of microscopic particles, atoms. Okay, so the uncertainty principles holds for microscopic particles only. Okay, microscopic particles only, right? And question number 28. According to uncertainty relation, the minimum uncertainty in the velocity of an electron orbiting around the nucleus of radius r is given by h cross by 2mr. So here we have h cross by mr. So we will be having h by 2mr here. So option A is correct. And the duration of a radar pulse is 10 power minus 6 seconds. The uncertainty in its energy would be, okay, so we know here they gave the duration, that is the uncertainty relation between the energy and time can be written in this form. Okay, can be written in this form, that is del t del e is equal to h cross. Okay, right, h cross. And once you substitute the values, okay, we are able to substitute the values, we write del E is equal to h cross by del T. So del E is equal to 6.646 into 10 power minus 34 divided by 2 into pi. So for h cross we can write it as h by 2 pi. So 2 pi is in denominator, 2 pi into 10 power minus 6, which is nothing but del E is equal to 1.05 into 10 power minus 28 joule. Okay, so question number option C is correct. Option C is correct. Okay, and 30. Let the uncertainty relation between del x del p is equal to h if the such nucleus is 10 power minus 5. The uncertainty in the momentum of proton remaining within the nucleus in the order of. remaining it is in the order of option is A. Okay, okay, try to give the answer, try to solve it and update it in our comment box. Okay, question number 31, again it's like del x, and it is given as del x is given as 10 power minus 15, and we have to find del p, which is nothing but 6.62 into 10 power minus 34. So make a substitution and you are able to find the answer as 6.62 into 10 power minus 19. Okay, so that's what the process of solving this. The uncertainty relation cannot be hold for following pairs. For position momentum we can write it. For energy and time we can write it. And for angular momentum and angle we can write it. We are not able to write linear angular momentum and angle. Okay, right. According to wave mechanics, a free particle possesses continuous energy. Okay, it possesses only kinetic energy. It doesn't have any potential. Okay, right. So we will stop here because in upcoming questions you need to know something about waves, wave function, energy levels of a particle in a box. Okay, so stay tuned for the next video and we will stop the session with 30 questions, and we have some questions to, I told you to solve some questions and try to give the answers, and for 26th try to give the answer. Okay, it's very important and easy problem, and in next class I will be discussing that one from 26. It's a somewhat, it contains some derivations. I will do that. Okay, right. Thank you for watching and keep learning physics.